Welcome guys, hope you're doing well. In this video we're going to take a look at some more solving trig equations, and pretty much we're just going to walk through some examples. Before I get started, I want to take a quick look and highlight the difference between an identity versus an equation. They look somewhat similar at first, okay? But you'll notice an identity, as I talked in a previous video, this is true for any value of x. No matter what x is, no matter what my angle is, any angle here will result in a sine squared plus cosine squared equaling 1. And so an identity is always true. An equation, on the other hand, is only true at certain points. Okay, and so that is the difference. Let's take a quick look at the first example here. So here we're needing to solve 2 cosine x equals -1. So we need to get x by itself. How are you going to do that? Hopefully you're thinking, well, first step is to divide by 2. I'm multiplying by 2 here, so divide by 2. So cosine of x equals -1/2. At this point, you've got two options. You can go with the calculator option. If you type in the calculator, you're going to use the inverse cosine, right? Or some of you are pretty comfortable with these and seeing -1/2, and you're realizing, hey, this is a 30, 60, 90 triangle. So the -1 is going to be here, the 2 is going to be the radius here. And so you're saying, hey, my answer here is going to be this angle. If you do the inverse cosine of -1/2, okay, now we need to talk, do we want to do radians or do we want to do degrees? It doesn't say here. So since it doesn't say, we can pick. You'll notice in the next problem they say in the interval 0 to 2 pi. So here we have to answer in radians. Here we have to answer in degrees. This one doesn't say, so we get to pick. And this one says degrees. You'll also notice some of these say between 0 and 360, 0 and 360, 0 and 2 pi. But these two just say to solve. When it says just to solve, this is really code for meaning solve, give all solutions. All right. So degrees or radians, which would you prefer? I'm guessing you would prefer degrees. So if we do degrees, we can see that this angle here in this picture is 120 degrees. If we type it in the calculator, we'll also get 120 degrees. And so this is my first solution, okay? And so you might be tempted to just say x equals 120 degrees and say, I'm done. If you would do that, you're wrong, okay? I'm sorry. You need to think all the way through. Remember in the previous videos, we talked about how cosine has this cyclical nature. And so there's going to be this place where we get multiple solutions. Now, this picture doesn't match this problem, but that's what's going on, is we get multiple solutions. So at the very least, we need to add 360k, where k is an element of the integers, okay? And so now this gives me half of the solutions. But if you think about your circle, there's another place on the circle where cosine will be -1/2. Cosine, you remember, is x over r. And so x is also going to... There is another angle down in this quadrant, I guess is what I'm trying to say, where the x value is -1, the radius is 2. And so when I have this angle here, I will also have a solution. So that's 60 more than 180. So 180 plus 60 is 240. And so x can also equal 240 plus 360k. And this is going to be your final answer for number 5. So hopefully that makes sense. Key is just to get the cosine by itself first, and then either think through it or use your calculator to your advantage. Even if you use the calculator, you have to think about the circle to get your second angle here. Once you have your two angles, just make sure to add 360k to get all of the coterminal angles. Each time you go around the circle, you'll have another solution. So hopefully that makes sense. I think I'll pause the video here.